Hi everyone, we are the team number 2, and the team members are Hannah Aguilar, Patricio Perez, Daniel Longoria, and Alexis Aviles, and we are going to present our assessment number 5, that is equal to the final report of the subject analysis of mechanisms. Our problem statement is that recently the world has been victim of a great amount of garbage, from eating residues to technological wastes. Also, the human have been trying to reverse this situation, but this hasn't been possible. For this project, we have been focusing on water residues. Around 10 million tons of garbage ends in the sea per year. The plastics production increases potentially as years come through. Unlike organic matter, the plastic doesn't disappear just as the other residues. Our main idea is to create an aquatic waste recollector, which is able to collect all the waste from the water, thanks to its repetitive movement generated by a motor.
Here is the table of contents that will be presented in this video. We're going to be discussion about solution proposals, definition of requirement, system description, design selection, synthesize, SolidWorks simulation, and MATLAB simulation.
And now we are going to start with the solution proposals. The first one is a 4-bar mechanism. This system was developed, and it consists on a fixed bar represented by 2 points. To each of these fixed points, a bar is attached, and with the opposite ends another bar that is connected in order to have the form of which the mechanism is formed. The main idea of this mechanism is to have 2 pairs of parallel bars, and this one will allow to rotate this mechanism around 360 degrees. Due to the fact that we have 4 links and 4 simple joints, in each arm we have a degree of freedom, which represents the movement from front to back and vice versa in a circular way. We think that despite not being the best option, it could be a good alternative to take in account to our final proposal.
Now, this system consists of a 2-slider crank, where thanks to a rotary motor, it will activate and make the mechanism work. This has 4 links, 2 joints, and 1 double joint in the operation of the mechanism. The rectangular link will be in charge of collecting the garbage to its length that will allow the collection together with the other slider crank. The mechanism will be able to pull the garbage due to its angular movement that becomes linear when it's placed ongoing.
Now we have another slider crank mechanism with a claw mechanism attaching to the slider or the piston of the slider crank. The idea of the main purpose of this mechanism is to recollect the trash that may be found in the water, like in the river or in the sea, by an operator controlling an stepper motor or a servo motor that will activate the slider crank mechanism, which eventually would control how the opening and the closing of this claw. One of the benefits of this mechanism is that the operator can adjust the amount that the claw is open and closed, so many different types of sizes from trash can be easily recollected.
This slider crank mechanism has 2 bars which connect with a basket that carries the garbage away from the ocean. This mechanism works with a small crank of 100 millimeters, a bigger link of 500 millimeters, and a basket. The crank is connected to a motor which causes it to start turning around a fixed point. Once the crank starts turning, the connecting rod comes back and forward, causing the basket to move, recollecting the garbage in the sea. This is why this mechanism has 1 degree of freedom. Now we're going to talk about the definition of requirements. The first one is the degrees of freedom. To facilitate and simplify the operation of our machine, it will have to be limited to only having 1 degree of freedom, which can perform the necessary action for waste collection. Then the engine. To delimit and make the operation of our mechanism easier, the intention is that it only has a single engine. This is in addition to reducing the complexity of the system. From an economic perspective, it's also beneficial to our mechanism. Then the size. This is an important element because we need to consider the amount of residues we want to collect from the water. Having a small mechanism will lead to collecting a little amount of garbage, which could be a disadvantage considering that the amount of residues increases potentially every day. Furthermore, having a bigger mechanism will lead us to use a more powerful source for it to move the way it is desired. Then the power source. The power source needs to be efficient for the movements we need our mechanism to do. We designed our mechanism with no need of having a precise control of the movement of its components. That's why we propose a motor that can be powered by an AC source. And then, but not least, the amount of residues. The amount of residues we want for our mechanism to collect is from 9 to 10 kilograms per minute. This is because, according to some facts, every minute a truck full of residues is thrown into the water, leading to 14 million of metric tons. If we collect the amount of residues previously established, we could clean 6 cubic meters in 1 hour, helping to diminish the amount of wastes on the water. Now, with the design selection, we chose this mechanism with a 4-bar mechanism, but in this case, we decided that none of its sides were not parallel. This to change its movement and angular position, where it was achieved that the mechanism could collect garbage in a more efficient way, as it will allow you to collect a greater amount of garbage.
Well, now we are going to check the system description. This system has 4 links. The A1 is work as frame. It's the ground of the mechanism. It's a 120 millimeters link, and this doesn't have a movement because it is fixed. The A2, corresponding to the crank, is an 85 millimeters link. It is attached to the shaft, which impacts it with the same circular motion. The A3, it works as a coupler. Its function is to transfer the rotational motion from the crank into a rock motion in the rocker, and it has a length of 125 millimeters. And finally, the A4 is a 130 millimeters link, and it works as the rocker. This is because it's a link that does not revolve and follows the link A3. Also, we have the actuator. The actuator of our mechanism will be an AC motor, and they generally operate in a 60 hertz current.
And now we have the synthesis of our mechanism. In this part, we basically make a mathematical analysis with the final decision. And also, we had to make different mathematical calculations using some trigonometric help. And also, we had to calculate the position with vectorial equations. And due to this, we had to pass to the velocity. And finally, we only made a pair of calculations to obtain the angular velocity in the different links of our mechanism.
Well, now we're going to be presenting the SolidWorks simulation. In this case, with SolidWorks, we generate these 2 graphs that represents the angular velocity from these 2 joints. We also can observe the vector velocity and the trajectory that these joints will have in the mechanism. Then we generate a MATLAB simulation where we obtain a very similar graphics from omega-3 and omega-4, which represent the angular velocity from these 2 joints. In this case, we can see that they are very similar graphics, so we can conclude that the calculation made by the mathematics and by SolidWorks and with MATLAB, they all 3 have a very similar result, so we can conclude that they are correct.
Finally, we have the references that we use for our final report. And that's all. Thank you for your attention.